El Niño and La Niña are events that are often talked about, whether on TV, in newspapers, or even at school. I'm sure you've heard a lot about them. But did you really understand what they are and how they work? Besides that, what are their impacts, their causes, and their consequences? That's right. In this video, we're going to talk about all of that in that clear visual way that I know you like. So let's get into the video. Hey everyone, hope you're well. I'm Paolo, your geography teacher, and it's always great to have you here on Heyo Ilustrada. Let's dive into El Niño and La Niña. It's kind of a complicated topic. I have to admit to you that it took me a while to really understand this myself, okay? So stay with me until the end, because I guarantee you'll leave this video understanding these phenomena perfectly, all right? And at the end of the video, I left a gift for you, okay? Seriously. So hang in there. As I always like to do here, let's start by defining things because I know that's your biggest question. What is El Niño? El Niño is simply the unusual warming of the surface waters of the Pacific Ocean. And La Niña is the opposite. It's the unusual cooling of the Pacific waters. It's that simple. All right, that's the end of the video. You can go back to your Minecraft now. Just kidding, guys, it's not over yet. Because it's not enough to just memorize that definition. You need to know what causes this warming and what causes this cooling, right? And that's what we're going to do now, answer these questions. But before that, let's just locate this phenomenon. Take a look at your screen. I'm showing a map. It's more or less in this region of the Pacific Ocean, see? Here on the west coast of South America, up to about the central part of the ocean, that's where this phenomenon will happen with greater intensity, okay? But then you might think, hey, Professor, that's really far from Brazil. How does that impact me? How does that affect us? But it does affect us, okay? It affects us a lot. But we'll talk a little more about that later, okay? Hold on. So, all right, I said at the beginning that both El Niño and La Niña are unusual events, right? Then you think, okay, if they're unusual, what's normal? And that's where we're going to start here, all right? Because if you understand how things normally work, from there, you'll be able to understand better what is unusual, what is abnormal, okay? Take a look at this diagram on the screen that I prepared for you. Take notes, and if needed, rewind the video to understand. Check this out. In this diagram, we have here, first of all, the west coast of South America, and on the other side, the regions of Asia and Oceania. And highlighted there, you can see the equator. And why is the equator important? Because it marks the equatorial zone, which is the part of the planet where the sun's rays hit with the greatest intensity. So, it's easy to imagine that the surface waters in this part of the planet are warm, right? And they really are. But pay attention to something very important. Here we have the influence of the so-called trade winds. What are trade winds? They are winds that blow, more or less, from 30 degrees to 0 degrees latitude, more or less in the direction you see here. Want to understand more about trade winds? You need to watch another video here on the channel, okay? It's showing up there in the card, up top. Watch it later, okay? Because it's very important. But for now, think of the trade wind as a kind of fan that's located right there on the coast of South America. And this fan pushes those warm surface waters over there on the coast of Asia and Oceania. In other words, all the warm waters go to that place. And then another very important phenomenon will happen called upwelling, which is when the cold, deep waters rise because the warm surface waters were pushed to the other side. So, the cold water will rise and occupy that space. And as this cold water rises, it brings with it a large amount of organic matter. And the cold water, besides that, also naturally has a higher percentage of oxygen. This strengthens fishing activities in the region, especially along the coasts of Peru and Ecuador. On the other side of the Pacific, in the western part, since we saw that there is a higher concentration of warm water, it will consequently create a low-pressure area. Consequently, this causes instability and a lot of rain in that region. And this air, which initially arrives there warm and humid, will rise, circulate, and return to the starting point, but now drier. And here we have the formation of the so-called Walker cell. Yes, this is the infamous Walker circulation, which you've certainly heard about. Remember, this is the normal pattern, okay? To make this even clearer in your mind, take a look at this little animation I'm showing on the screen. You can see the trade winds as if they were a fan. That pushes the warm waters from the eastern part of the Pacific, sending them over to the western part. And then you can also see the upwelling, right? Which is this rising of deep, cold waters. And on the other side, the instability causing rain. And then the closing of the Walker cell above, as I explained earlier. Be honest, guys, this is pretty easy, isn't it? It's not that hard, really. And if you understand the normal behavior, understanding the abnormal will be a piece of cake. Easy as pie. Let's see that now then. It's El Niño. As we've already mentioned, El Niño is the abnormal warming of the waters there in the Pacific. But why does this happen? You remember that fan analogy, right? The trade winds push the warm surface waters from the eastern part to the western part of the Pacific. So El Niño happens when this fan breaks, so to speak, and it doesn't blow as strongly anymore. In other words, it is caused by the weakening of the trade winds. So if the trade winds weaken, this warm water isn't pushed to the other side. It stays there, stagnant on the western portion of South America, even reaching the central part. So that region ends up getting warmer than usual. Professor, why do the trade winds weaken? I don't know. I can't explain it. Not even science can explain that yet. So I'm not even going to try. There are hypotheses, but I'm not going to talk about them, okay? But the fact is, if the trade winds don't push the warm surface waters, upwelling doesn't happen. And if upwelling doesn't happen, it's going to cause a big economic impact, especially for fishing activities, right? They're going to be directly affected by this. And here's an interesting fact. The fishermen in the region noticed that this phenomenon usually happened around Christmas, right? Reducing the amount of fish and everything else. That's why they started calling it El Niño, which means the boy, right? Referring to the baby Jesus, the birth of baby Jesus. All right, that being said, look, something very important. During El Niño, the dynamics of the Walker circulation change. Because the low pressure zone will form there, more or less in the middle of the Pacific Ocean, so that area will be quite unstable, generating a lot of rain, and also causing a split in this cell, as you can see in this illustration. I know you got it, but let's watch this little video again. Look, our little fan breaks, right? The trade winds, so the warm surface waters won't be pushed. They'll stay there on the surface, preventing upwelling. And there again, an area of instability, of low pressure in the central region of the Pacific Ocean, breaking the Walker circulation cells into two parts, okay? Pretty simple. Professor, what about La Niña? La Niña is the opposite. Think of La Niña as a phenomenon that happens in opposition to El Niño. So the effects are also opposite. If El Niño is the warming, La Niña is the abnormal cooling. So again, imagine that our fan over there represents the trade winds. Instead of breaking, now you cranked it up to 220 volts and it got really strong. So the winds get stronger and the warm surface waters are pushed even further to the western part of the Pacific Ocean. So the upwelling happens even more intensely than usual. That's why it causes the abnormal cooling of the Pacific waters. Now, to wrap up our video here, let's quickly talk about the consequences, okay? Take a look at this map. It illustrates the main climate consequences of the El Niño phenomenon. The west coast of South America will become rainier and warmer. Meanwhile, that northeastern part of Brazil will become even drier than usual. The southeastern and southern parts of Brazil tend to become rainier during this period. But in a La Niña year, as you can see on this map, exactly the opposite happens, right? Remember when I said that La Niña is an opposing phenomenon? Or the opposite of El Niño? So that's perfectly illustrated in this little map here. If necessary, pause to take notes, okay? And what about my present, teacher, the one you promised? All right, in the description of this video, I'm leaving the link for you to download the mind map from this video, okay? I don't usually do this because, as you know, we have our mind map kit here that I sell to supplement my income, right? To keep the channel running. This time, I'm giving you the mind map for this video as a gift. Just go download it, and don't I deserve a like and share for that? And to help you get even better at this topic, watch this video on your screen about the dynamics of the general circulation of the atmosphere. Okay? Thanks for sticking around until now, and see you next time. Bye-bye.